Uh, let's go through LeetCode number 57, insert intervals. For this question, it gives us a two-dimensional array that is intervals. And it gives us a new interval. Let us to insert a new interval to those intervals and get the inserted interval array. The question says that the intervals is sorted. And we need the result also be sorted. And also the intervals does not have any overlapping intervals. So for this question, that means let's see, it is sorted by start I, right? So we'll see this 1, 1, 3, 6, 8, 12 is sorted. And you see that this kind of intervals does not have a lapping. Actually, all the numbers are sorted: start, end, start, end, start, end, start, end, start, end. So for this question is that we have the intervals and intervals. And we have a new interval. For example, it is here to here, right? We just iterate this kind of intervals list from left to right. We know if this interval is left, its end is smaller in the unit new intervals end start, we just put those part or the intervals before this to a list. And also if the intervals the start is greater than new intervals end, we just put that on the list as well. And for the middle part, we need to merge to one interval. So we just iterate those kind of intervals one by one. So the time complexity will be O(n), space complexity will also be O(n). Someone may consider because these numbers are sorted, right? So there is another thinking is that we may, for example, binary search for this value, new start, and find the last end, which is smaller than this, and also this new end, find the first start, which is greater than this, and have this to copy to a list. And for this part, we just compare this value and this value and then this value, and then put the other part still in a list and convert it to interval array. But this method is use binary search to compose the result is still O(n) time complexity. Thinking about the worst scenarios that we need to iterate this almost n times, right? This and this. So still O(n) time complexity. So so I think it's not worse for us to write the binary search way. So for this question, we just iterate the intervals one by one. So let's write code. We need to have a list to store the result. Let's get the intervals array's length. In the new interval, we have a new start equals new interval 0, and the new end was new interval 1, right? And let's get an index I. Let's have it to be 0. And for I smaller than n, and we'll say this intervals I is end, right? And that is 1. smaller than new start, plus plus. We just added this part to our list. And also, after that, our I go to the part which have overlap. So for I smaller than n in the intervals, is start, right? Start is smaller equal to n end. So we'll see, we iterate this interval, the start equals intervals I 0 into end equals intervals I dot 1. And we need to update in start equals max dot max min start in start. And actually, this one we don't need to update even, right? We just need to update the end was max of max and end. We, I mean, the instart we just need to update once, right? Instart is definitely there because for the rest, the start will always be bigger. So we just need to update this one means then, well, for the rest, that is also no overlapping. We have this add. And then we return list to array new meet there. Yeah. Right. So this is the first part. No overlapping. This will be the second part. This is third part. And this is also no overlapping. So doing like this way, the time complexity is O n, and the space complexity is also O n. Here, we need to add the middle interval into it. So Mhm. Doing like this way is that they may have no overlapping. So let's get we don't separate this one inside.